Okay, page 8 in your work packet. So notice here, you're going to be converting between moles and mass. Moles and mass. So if you're converting from mass to moles, that means the mass is always going to be in grams, and moles is abbreviated MOL, and we're going to be making this conversion from grams to moles. That's another way we often say it. Now, to do this kind of problem, you are going to need molar mass. So don't forget, you're going to need. Need should start with an N. You're going to need molar mass. And I'm going to abbreviate molar mass with a capital M for molar mass. So we're always going to start with a certain number for this kind of problem. If you're given a certain number of grams, that is going to come from the problem. In other words, in the problem, you're going to be given grams, and that's what you start with right here. And then I'm going to draw a mathematical statement that kind of looks like this. That's what we're going to use all the time. And what happens here is we're just putting in a fraction where you multiply whatever is on top of the fraction and you divide by whatever is on the bottom of the fraction. Now, what we're going to do here is, since we have grams here, I'm going to put the same unit down here. Now, why are we doing that? Well, in math, we know that if you have the same number on the top and the same number on the bottom, they factor out. We say we can cancel them out because they actually just change into 1. Now, grams divided by grams is just a 1, and so the unit can go away. And this grams down here is actually the molar mass, and that's the number of grams in 1 mole. So this number that has mole by it, this number that has mole by it in all the problems we're doing this week and the first week in January and probably the second week in January, every time you write a mole, you'll write a 1 by it. And what that means is these units canceled, right? And so the unit that is left is just moles. So remember, that's what we wanted up here at the beginning of our problem. So that's just a 1 for 1 mole. No, that's not, sorry. Up here is a 1, but that's the answer to our problem. We're going to work some examples, and you're going to be able to go back and look at these notes to see exactly what I'm talking about. In fact, let's go right now to this side of the page where it says how many moles are in 132 grams. So you notice we are starting with grams of CO2, right? Now I'm going to shrink this a little bit, but I don't know if I can get it all here. And I'm also going to switch to a little bit different color so you can glance up and see where you're writing. So given in the problem is 132 grams of CO2. And it's the best practice it's the best practice to write that specific chemical there, because that will actually help you later on. And we're going to use the mathematical expression that looks like this, where really we're just multiplying by a fraction. And to multiply by the fraction, you're going to always multiply the thing on the top and divide by the thing on the bottom. That's what fractions do. Like, right? If it's 1/2, you multiply by 1 and then divide by 2. And that will always give you 1/2 of whatever that number is. But in this case, we're going to do just like we did over to the left. We're going to put 1 times a mole on the top, because that's the unit we want to come out in. Remember, how many moles is the thing we want to know at the end of this problem. This is what we know at the beginning of this problem. We know we started with 132 grams of carbon dioxide. We want to end with moles of carbon dioxide. So, what is the molar mass of carbon dioxide? That's what we need down here in the denominator. That's what we need right there, is the molar mass. Well, you remember how we do this. I'm going to work it right over here. What is the molar mass of carbon dioxide? You have room, I hope, on your paper right there as well. The molar mass of carbon dioxide is, hello.
So we have a form that we're working on for AP Gov, and we're just hoping that if we could put it up.
There's some tape right inside the first 2 drawers there. You're welcome to tape it on the walls there. Sorry, the last 2 drawers, next 2 drawers to your right. There should be some blue tape. Is there some? Yeah. Okay. I'm going to go on because I'm recording. So you want to come get in the picture? Yeah. This is government class. Yeah. They're interrupting our lives today. We're taking a little brain break here. That's what that's called, a little brain break. Okay. How do you find the molar mass of carbon dioxide? Is that going to work for you just to tape it up there? So anywhere there. Probably up higher will get more attention. And you're welcome to put one above the Purell dispenser there too, right over your wherever you want to put it. Okay, how do you find the molar mass of carbon dioxide? Well, we have 1 carbon, and we look carbon up on the periodic table, and we find 12.01. So we have 1 times 12.01. That's the mass of the carbon in carbon dioxide. But look, we have 2 oxygens. Dose. 2 oxygens. So that's, we look up oxygen on the periodic table, that's 16.00. 2 times 16. Get my calculator out, I do 2 times 16, and I calculate 32.00. So remember, the molar mass is the sum of all the atoms that are in the formula. So now we have all 3 of those atoms, and we just add them together, and we get 44.01. Hello?
Sorry for the interruption, Mr. Thayer.
It's okay.
Can I have Christiana Walter to the front office with anything?
Okay.
Thank you.
Thank you. Where's Christiana? Okay. Okay. So that's 44.01 grams is 1 mole. So that's our molar mass, and it's going to go right here, 44.01 grams of carbon dioxide is 1 mole. That's what that fraction right there is telling us, 44.01 grams per 1 mole. So now we can calculate this, and I hope some of you have calculators on your desk. If you don't have one, I'm going to encourage you to find a calculator over here. If you want to walk over and get one, feel free to do that. It's good to do this because you're going to develop muscle memory of doing the calculation and looking at it. And you're just going to develop that skill of solving these problems of converting from grams to moles. So in my calculator, I'm going to push 100. I got to turn the calculator on. I'm going to push 132 times 1, because 1 is upstairs, divided by 44.01, and I am going to get 2.999. That's what my calculator says. I'm just going to round that to 3. 3, the unit that didn't cancel. Go ahead and cross these units out that cancel. What unit is left? 3 what? Well, the thing that's left is 3 moles of carbon dioxide, CO2. Now, you're saying to yourself, why is this a practical thing for me to learn? It turns out that this particular skill we're developing here of dimensional analysis and unit conversion, you're going to find other places you can use this no matter where you go after high school. You're going to find places you can use this. If you keep your eye out, you will find them. So that's how we find how many moles are in 132 grams of carbon dioxide. Now you're going to find the skill may not be from converting moles to grams or grams to moles. It may be totally different, but it's still going to be this dimensional analysis. It's a useful thing. Okay. I'm going to move to the second half here. Now, in this particular problem, we are starting with moles, and we're converting to grams. Remember, anytime it says mass, it means grams. For us, that mass will be in grams. So we're converting from moles to mass. So the thing that's in the problem to start with, let's find a different color just for the fun of it. The thing that's starting in the problem, that's given in the problem, is going to be moles. So you're always just going to, if it starts with moles, you're going to have a conversion factor where you want moles to go away and you want to turn it into mass. So you're going to have some moles in the problem, and the question is going to ask about grams or ask about mass. And to do that, you're going to want to be sure that the mole unit here is on the bottom and the mole unit here that we're starting with is on the top, because if it's on the top and bottom and it's the same thing, you can factor it out. You can cancel it out. It just changes to 1. Like if you have X on the top and X on the bottom, you can factor them out. It's the same thing. These are simply like numbers or variables in your algebra class. And we're always going to be multiplying by what's on the top and dividing by what's on the bottom. And the number that's going to go with mole is still going to be 1. So you don't need to write anything else for moles other than 1, because it's simply 1 mole is equal to the molar mass. So remember, you're going to need the molar mass for these problems as well. Don't forget, you're going to need, oops, that was a funny looking N. You're going to need molar mass. Molar mass is your friend. That's why we've been practicing it quite a bit over the last 2 weeks. So, let me look here and see. Okay, one more thing we want to mention is what this will result in is a unit of grams that didn't cancel. So we're going to come to grams of whatever chemical. We've changed moles to grams using this conversion factor. Let's look at an example of this kind of problem. I'm going to give myself a tiny bit of space by making this grams smaller. Okay, how many grams are in 2.5 moles? So I'm going to label this as the thing we know at the beginning of the problem, and how many grams is the thing we want to know about at the end of the problem. Right now, it's unknown. What is this number of grams? We're going to find out. And we're going to set it up the same way we have it here. So I hope this is big enough. If you need me to write bigger, I can do that. Of course, we're going to start here with the thing that we know. We're just going to start with 2.5 moles of water. That's what we're starting with. We're going to put this conversion factor mathematical expression in, which really simply means we're going to multiply by the stuff on the top and we're going to divide by the stuff on the bottom. But what goes on the top and bottom? Well, we want the same unit that's here on the top to be here on the bottom. So that's going to be moles of H2O, so that they will cancel out. And what number always goes with moles? What number? 1. 1. And 1 is your friend because it's so easy to multiply by 1 or divide by 1 because it doesn't change the number at all. But up here we need the molar mass of water. How do we find the molar mass of water? I know, you're well ahead of me. Some of you already have it. Maybe you remember it from other times you've calculated the molar mass of water. The molar mass of water is 2 hydrogens. Each hydrogen is times. Each hydrogen is 1.01. So 2 times 1.01 is 2.02. And, molar mass of H2O. Because I've got to see what else is here, I need to find the molar mass of all the atoms in the formula. And that's not 10, that's 1 oxygen. 1 oxygen. I look up the molar mass of oxygen on the periodic table, and I find it's 16.00 for a total of 18.02. Oh, sorry. I got ahead of myself. 16.00 for a total of 18.01 grams per mole. 18.01 grams. So 1 mole is the same as 18.01 grams of water. So I do 2.5. I'm going to put this into my calculator. I'm going to multiply by the things on the top. I'm going to divide by the things on the bottom. So I'm doing 2.5 times 18.01 divided by, there's a 1 on the bottom, and that is 45.02. I'm just going to round that to 45 And the unit that didn't cancel is grams of water. 2.5 moles of water is the same thing as 45 grams of water. So, that's how we do these kind of conversions. So I'm going to stop my video because that's getting kind of old. Come on, video, stop. How long have you been